Good morning, class. We're going to do a little review of medians, altitudes, and perpendicular bisectors. We discussed this earlier in the year, but we're going to kind of walk through it again. So first talk about the medians of a triangle. So if you're going to draw a median, you start from a vertex, you go to the opposite side to the midpoint. So this CM would be the median of the triangle because it goes from a vertex to the midpoint of the opposite side. An altitude is a segment from a vertex to the opposite side and it forms a 90-degree angle or perpendicular to that side. Okay, so that's altitude. So we're going to take the first couple here. We're going to draw medians. And a triangle has three medians, all which would be inside. So for example, if we put in that and we draw the median, it has to be inside the circle. Inside the triangle. And if we were to figure that out, probably about there. And you get the idea. Again, that would be a median. And the reason it's a median is because these two sides are equal. Every triangle has three altitudes. Some are inside, some are outside. So if you have this where it is acute, you'll notice that all of the altitudes are going to be inside. Okay. But as we go to other triangles, we can see special properties. So if this is a right triangle, and we're trying to draw that one, that looks just about 90. But from this, the altitude is the side over here. And for this one, it again is the side over here. So that would form 90-degree angles for those three. And then if it's obtuse, we have the potential. So this one is inside, but this one you can see is going to be outside. So most of the time what they'll do is they'll represent that with a dotted line just to kind of represent it outside. And that's going to form a 90-degree angle. Let's get that off there. Sorry, we're frozen for a second. There we go, that looks a little better. And still frozen. And come back on here. Okay, now we're connected. Okay, and we're ready to go. And then this last one from over here, what you're going to need to do is extend this line and then draw this down here, and again you see that that can be outside. Okay, so let's try to work through a couple examples here. A perpendicular bisector when a line, segment, or ray is perpendicular to a given segment at its midpoint is a perpendicular bisector of the segment. So what you have here is that this xy, yx, the ray xy, and the segment x are all perpendicular bisector. That means any point on this line is equidistant from A and C. So draw a median from A, an altitude from A, and a perpendicular bisector. So in some of the shapes, you'll find that they are going to overlap. When we have this isosceles triangle, this has special properties for us. And so if we draw the median, I'm going to just draw as a line. Okay. And we see here that that means that's the median. We can prove this fairly quickly that that's also going to be the perpendicular bisector when this is isosceles. So when we draw for B, when we draw the median, oops, just going to extend that line. Okay, that's our median. And for this, and our altitude from A would just be the segment AC. If we draw our line from down to there, but if we're going to draw the altitude from A, that is going to be outside. Okay. So if AB is congruent, the measurement of AB is equal to the measurement of BC, then you know that segment is the median. PC is a perpendicular bisector of segment let's see, if PC is a perpendicular bisector of BD, then you know that BC equals CD. If APD is a right angle, then AP and PD are altitudes. If PC is a median of the triangle PDB, then PC is a perpendicular bisector of BD. PC and AC are both altitudes of this triangle. That means that ACP is a right angle. Okay. And then just to sort of emphasize one of the proofs that you're going to work on tonight, if we have a point that it's on the perpendicular bisector, if and only if it's equidistant from the endpoints. Also, when you talk about a bisector, a point lies on a bisector if and only if it's equidistant from the two sides. So this is where we can do perpendicular bisector implies so that implies AX is congruent to AX is congruent to segment BX. We can also do the converse of that. That's because of the if and only if. Okay, and then the same thing we can do for the angle bisector. If we know this is an angle bisector, we would then know that that XB is going to equal XC. If we know XC equals XB, then we know that that X lies on the angle bisector. So these again, if and only if, so we can use the implies setup for that as well. Have a great day.